welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. All right, hi everyone. Welcome to the House of ZK Radio. I'm Alice, host of House of ZK. I'm here with Uma, who is co-founder of Succinct, and we'll be diving into real-time proving networks, Succinct's latest developments. Really excited to have this conversation with you today.
Yeah, super excited to be doing it in person.
Yeah, awesome. I mean, we've been doing like a lot of these virtually, I think. So it's one of the first times we're doing this podcast in person, which is super exciting. But on the topic of real-time proving, I know that Succinct is one of the ZKVM teams that are making quite significant strides just on real-time proving. But curious to hear its effects on the user experience side once we reach like full real-time proving. What can we expect? And also, are there any types of new kinds of applications that can be enabled?
Yeah, so maybe to start off with a brief recap of what real-time proving is. Real-time proving is this idea that you have Ethereum blocks, mainnet Ethereum blocks, and you can take them and generate a proof of them in less than 12 seconds, which is the current Ethereum block time. And why real-time proving is useful is because in Ethereum L1 today, you have this like gas limit that's 30 million gas, and there's an upper bound on that because every node has to kind of re-execute the transactions, and there's other reasons there's an upper bound, but real-time proving helps break through that bound. And so now if you have real-time proving, you can increase the gas limit to, 300 million, 1 billion, even higher, and you can generate proofs with these blocks, and you can still have the network be verifiable, but have like unlimited throughput. And so that's why real-time proving is really powerful. And I think the new types of user experiences is really enabled through scaling Ethereum L1, which has obviously been a really popular topic recently.
Yeah, absolutely. So instead of having these validators re-execute an entire blocks, they can just have these proofs that are generated to avoid that re-execution. Yeah, got it. And that's how we can scale to even like 1 billion for the gas limit. Got it. And I wanted to also ask you about proving networks as well, because I know that Succinct, in addition to developments like with SP1, is also building your own prover network. So what's the role for prover networks in enabling real-time proving? And I know you guys also emphasize like the importance of enabling the proposer and prover separation. So can you speak a little bit about that as well?
Yeah, so real-time proving is awesome because basically now it becomes a part of like the Ethereum L1 block construction process. And in that world, you have basically every single block. The proposer for the block needs a proof to accompany the block. And obviously Ethereum L1 is a protocol, and where is it going to source these proofs from? Well, Ethereum L1's not going to use like some SaaS service, right? That's kind of like a non-starter. And so it's going to source its proofs from a decentralized protocol where on one side you have like every single block's proposer asking for a proof. And on the other side, you have all the provers all across the world who have their own custom GPU clusters set up that are generating these proofs in real time. So the prover network is just a really simple marketplace protocol where it kind of like conducts this competitive auction between all these provers all across the world. And then they basically compete on the price to generate a proof and then can send the proof to these proposers. And what's really interesting about our prover network is because we knew latency would be super important. Like obviously you can't conduct the auction, over a few seconds if the proof needs to arrive in less than 12 seconds. So our prover network really, really optimizes for latency. And I think that's kind of one of the distinguishing factors versus other prover networks. So basically we have the system where the auctions are conducted off-chain, settled in real time, so like in 400 milliseconds, and then the prover can just start generating the proof like very, very quickly and send it back. So yeah, prover networks are just the protocol that kind of like is a marketplace between provers and people who want proofs.
Got it. And going into more about the ZKVM side, right now, based on kind of Justin Drake's recent proposal of how we can expect the enshrining of ZK proofs generated by ZKVMs into the L1, based on that, there's also some talks that we're eventually going to see kind of the convergence towards one type of ZKVM. Right now, there's like almost 30 that are available, and they're all trying different kinds of design considerations, different ISAs, different proof systems. Like I know with the with HyperCube, you guys are looking into multilinear as opposed to the Stark-based proof systems, and even like, for example, with customized ISAs, ZKVMs are looking into that, and optimization techniques as well, like you guys, as well as some other ZKVMs, parallelization, recursion, using of precompiles, things like that. So wondering, just based on kind of your thoughts and opinions on this, are there any types of like ideal design considerations for a ZKVM, especially if, say, one type of ZKVM model were to be used for scaling the L1?
Yeah, so I think one interesting thing to talk about is like will 30 ZKVMs exist in the fullness of time? I mean, obviously ZKVMs are super hot right now. They're probably like the hottest area of infrastructure. And so that's why, you know, there's 30 people doing them. They have all sorts of small tweaks. But really the core of most of the ZKVMs on that list is actually very, very similar. And in fact, I think even a lot of the ZKVMs are very, let's say, inspired by SP1, or maybe even like kind of forks of SP1 where they add their own clever tricks on top. But the truth is, a ZKVM is really deeply complicated to make. Just to give you an idea of the tech stack, you need to have like a frontier understanding of cryptography. Then you need to build a prover. So you need to like, you know, arithmetize all your RISC-V, 32-bit, ISA, and then you need to also build the proving protocol. Maybe there are some of the out of the box libraries can help you, like Plonky 3, or with our upcoming HyperCube release, we're going to have a multilinear library that other people can use. And already all of that is like very complicated, but that's just the beginning. Then you have to do this recursion thing where basically to prove programs of arbitrary length, you have to be able to generate a bunch of proofs, usually in parallel, and then stitch them together using a recursive circuit. So to do performant recursion is very, very difficult. So you have to do that. You have to do a Grot16 or Plonkish KZG wrapper where basically, usually the Starks are pretty big. They're like 300 kilobytes to like 1 megabyte. Ethereum can't, accept that, so you have to wrap that in like a snark-based system. And then finally, to actually get this to performant, you have to write a GPU implementation of all this stuff to get it to run on this hardware to be cheaper and faster. And then that's not all, because to get it really, really low latency and generating proofs in real time, you have to run all this stuff in parallel on a large-scale GPU cluster. That's like hundreds of GPUs. So making this whole system is very difficult, has a lot of steps, requires a lot of expertise. And in the future, these things are going to be formally verified, which requires a lot of capital to like pay people to do the formal verification. There's going to be kind of compounding effects of security. Like if one ZKVM's been used in production for a long time, you probably trust it more than some like new thing around the block. Even if it's only like 10% faster, you're going to say, hey, I'm going to use the old thing because it's probably a lot more secure. So I think, in the end, the landscape might look like there's 2, maybe 3 ZKVMs that like get widely adopted and used. Similar to kind of there's OP stack and ARP stack, but that's all. There's not 30 different rollup stacks that survive the test of time. And so when Justin Drake talks about enshrining a ZKVM, I think they actually also acknowledge this reality where they're like, practically speaking, there's only really going to be 2, maybe 3 ZKVMs that end up mattering. And so maybe at the end of the day, in like a few years, when we have something that's formally verified, it's just good, it's very performant. Everyone's going to like start, if it's open source, people will start improving that piece of code and technology. Maybe we'll just enshrine it in Ethereum as just like the canonical ZKVM. And enshrinement and picking a certain ZKVM has a lot of benefits because, like, if you're opinionated, you can kind of move faster. There's even other technical benefits. So yeah, I think that's how I at least think about what Justin Drake says about the path towards enshrinement.
Got it. Yeah, and it's really great that you mentioned that ZKVMs itself, it's not just a single component; it's an entire system that you need to think about. There's the compiler, and then there's prover, and then you mentioned about kind of the recursion aspect, and then using Grot16, making it EVM compatible. And then there's verification, and then even with the, say, GPU orchestration, having those proofs being generated in parallel, and then even with proving networks as well, it's an entire system that you need to think about. And like right now with this experimentation phase, we're seeing a bunch of those tweaks that different ZKVMs are making, which, is good. It's always good to experiment, but kind of in the long term, perhaps we'll see just the enshrining of 2 to 3 ZKVMs. Yeah, got it. And on the topic of also benchmarking as well, which is like a really big topic within real-time proving and what the ETH Proofs initiative is really focused on. So just curious to hear your thoughts on some of the properties of benchmarking that you think should be prioritized the most. So of course, there's like those efficiency-related properties relating to speed and then also proof costs. But how about things like security properties or even like memory usage, resource utilization? Are there any types of properties that you think that ZKVMs should really consider when it comes to benchmarking?
Yeah, benchmarking is always a really complex, multidimensional thing. And I don't think there's a one-size-fits-all answer on like, this is what the benchmark should be. It's more like the benchmark fits the use case. So I think even in AI, like there's not just one model that's strictly the best on any set of benchmarks, right? Anthropic models are the best at coding. OpenAI models are maybe the best at these like consumer interactions. Maybe Grok comes out there and actually it's a little better in like reasoning, right? So I think similarly, like the benchmark depends on what you care about. So if you care about real-time proving for Ethereum mainnet blocks, then I think the benchmark's actually pretty straightforward. It's like you take mainnet Ethereum blocks, so that's kind of like your benchmark workload that remains consistent across the different ZKVMs, and you measure, how long does it take to generate a proof of the execution of this mainnet block. Even there's some dimensionality to it, so you can say how many GPUs does it take. So for example, with SP1 HyperCube, if you just care about proving 50%, like half the block, so at the average or median block, you can probably do it in like 60 GPUs. But if you want to get to like 93% coverage in 12 seconds, then you need like 150 or 160 GPUs. And those numbers are actually going down like week by week as we improve the performance of those systems. But yeah, that's like something kind of interesting to consider is, what percentage of the blocks do we want coverage on? How many GPUs like do you need to like do 100% of the blocks? Those are some kind of like factors or trade-offs. Other than that, I think at least for real-time proving, because your workload is standardized, that's pretty easy. There are other benchmarks where, people are benchmarking, like computing the, nth Fibonacci number. And sometimes like ZKVMs are very, very fast at that. But if they don't have precompiles, for example, ZKVMs can be extremely fast at like computing the 100th Fibonacci number, but bad at real-time proving for a real Ethereum mainnet block, because there it's really important to have Keccak precompiles or SecP 256K1 precompiles. So yeah, I guess that's like some of my thoughts on benchmarking, but I could talk about benchmarking for a long time. It's like very complex.
Yeah, very, very big topic, but basically really dependent on the use case that you're going for. So like you mentioned that just doing like comparing toy examples, like the proving a Fibonacci sequence, very different from a real world example, like proving an EVM block.
Yeah,
got
for
it.
Sure.
And onto the topic of more into proving networks, specifically like Succinct's proving network. What types of incentive models do you guys really prioritize when it comes to properly incentivizing all of the participants in the network, like with the auctioneers, the provers, even the proof requesters? And I know you mentioned previously that the latency aspect is something that you really prioritize on, but curious to see like where these how the participant dynamics really relate to the incentive models that you're offering.
Yeah, so our incentive model is actually really simple. Basically, like a requester says, hey, I have a proof that I want for this program for these inputs, and I want it by this time, and here's the max price I'm willing to pay. And then right now, what we're taking to market is a really simple like auction where people compete to provide the most competitive price, and then if you provide the lowest price, you get chosen. And then you have to generate the proof, deliver it by that deadline, and if you don't deliver it by that deadline, you get slashed. So the participant can also like choose the amount of like stake that they want slashed, and provers with that amount of stake, only the provers with that amount of stake will be allowed to participate in the auction, right? So that's a protocol. It's very simple. It's very flexible. It's left up to the participant. In terms of additional incentives for the network, obviously you can imagine that like when we're bootstrapping or ramping up the network, or even in testnet, that provers get kind of like an extra reward from the network in, you know, in the form of like our proof token or something like this to incentivize them. But in the long term, like the idea is that, you know, the fees that requesters are paying to the network are the thing that the prover is ultimately competing for. So it's not really like an emissions-based model or anything like that, at least for right now. It's much more just like, it's a marketplace and here's what you're competing for.
Got it. And I believe from when you guys first proposed the prover network in the earlier white papers, you also mentioned about a proof contest model as well. So are there any kinds of plans in transitioning from the auction-based model to that proof contest model?
Yeah.
Okay.
Yeah, so that's a great point. So the auction model is really simple. And then in our white paper originally, we proposed this proof contest mechanism, which is still an auction. And it's actually really similar to the like a normal, just like lowest price wins auction. But it, you know, without getting too much into the weeds, it has this mechanism where the lowest price person doesn't win every time. It's more probabilistic based on how far off you are from the lowest price. So if there's two people who are bidding, one guy's at $1, one guy's at $2, another guy's at $10. It's not the guy who bids $1 wins every time. With some chance it goes to the $2 guy, and with some smaller chance it goes to the $10 guy. And it has this configurable parameter to tune like how frequently these like non-cheapest people win. So the reason we have this proof contest mechanism is to prevent concentration in the network. So if you always just award the proof to the person who's the cheapest, that could lead to someone who's like just totally monopolizing and dominating the network, which is bad for the long-term health of the network, right? Because like then someone monopolizes it, kicks everyone else out, and then one day like they can just like extract and charge a bunch of rent or like, you know, start doing bad stuff. So yeah, we have this like tunable parameter that makes it, you know, a little more like, yeah, just less concentrated. So that's something I think, plan on implementing in the future. But I think to start, like, we're keeping things pretty simple, seeing how it goes. It might be the case that, like, maybe a monopoly just naturally doesn't really emerge. But, you know, if we see that behavior, then maybe we'll implement this proof contest mechanism and, you know, kind of have that as, like, a tool to combat that.
Yeah, it's great that you have that kind of tunable parameter there. I can really see it helping against that centralization piece. Yeah. And, you know, a lot of proof networks, a lot of people are advocating it for it to be like really decentralized. So really great that you're like so much thought is being put into this. Yeah. And on the architecture side, I know that the prover network is also based on like the Succinct team worked on a verifiable app or VAP component. So curious to hear about the intentions of focusing the architecture based on the VAP and incorporating both like off-chain and on-chain components.
Yeah, so earlier this year, we released a paper with Layer Zero called Verifiable Applications, or VAPs for short. And the idea behind a verifiable application is that a lot of the logic can, when you're building an application, you should just be able to write it with normal code, just like normal Rust, as you would a normal web server backend, but then stick that business logic in a ZKVM, make it verifiable, and then boom, like you get a lot of the great properties of Web3. It's like verifiable, you know, people can't steal your money, but with the developer experience and speed and user experience of Web2. So when we were building our prover network, we realized a VAP was actually a really great fit for it, right? Because we want the real-time UX of Web2. We want the auctions to happen in like 400 milliseconds, or, you know, even lower. So we want all those benefits. We want it to be super cheap. Even as we were coding it ourselves, we wanted to be able to just like write normal Rust code to be like, oh, this person, when this proof gets fulfilled, this person gets the money, whatever, right? So Yeah, we didn't want to write it as just like a smart contract on like Base, for example, because like Base's block time is 2 seconds. That's a total non-starter for like the auction to settle in like on-chain in 2 seconds, right? It's like just too late. So we're like, okay, let's just code it as normal in Web 2. But then, so all the auction and matching happens off-chain, but then the verifiability comes in on-chain, where basically when the match happens, we make sure that like the flow of funds goes from like the user to the prover, and so we can't just take your money. So when you deposit into the protocol, the only way your money can move is like if you signed a request and it got matched to a prover and you were okay with like, and the proof was fulfilled, and so someone gave you the thing you originally asked for. So yeah, that was kind of some of the reason why we decided to structure it as a VAP. It was like really product driven, really pragmatic, and honestly, we hope that people take our prover network VAP, which is open source, by the way, and copy paste it, make their own, make a payments VAP, make an exchange VAP, like just do whatever they want with it.
Yeah, and it's really cool that you have that kind of some of the benefits with Web 2, especially when it comes to that low latency.
Yeah.
So it's really great that you're incorporating that. And also very curious to hear more about just like decentralized proving in general. I know that Succinct is really heavily focused on the decentralization aspect, but curious to hear about any like trade-offs that you see between decentralized proving networks versus more centralized proving models. If there's like a need for both, if there's kind of like advantages present in one that aren't present in the other, or like which types of scenarios would a user find a decentralized proving network more advantageous versus a centralized one?
Yeah, so I think like you have a decentralized proving network protocol where the one thing I do want to clarify is it's more of a marketplace where you have a bunch of actors all across the world who might be running like their prover in one data center in like one centralized location, but they're all competing on a decentralized protocol. Versus, for example, a SaaS agreement with like Succinct to just run their centralized prover and give me proofs. I mean, there's definitely advantages to the centralized model. Like, for example, Succinct Labs can sign contracts with you being like, hey, here's our SLA, here's our guarantee. If we just one day stop and disappear, like you can sue us, things like that, right? A decentralized protocol can't really sign legal agreements, but it can enforce certain guarantees in a much more programmatic way, right? So you can send it a request, and then it can give you the guarantee that like if the request isn't fulfilled, this amount of like proof token will be slashed. So that's kind of like the decentralized answer to an SLA. But obviously like a legal agreement, maybe can be more flexible. It can be like, hey, someone has to like respond to pager duty within 15 minutes if, the proof gets dropped. A decentralized protocol doesn't have that notion. So I think there will maybe always be room for centralized service providers on top of decentralized protocols, similar to kind of the RAS model, where like, OP Stack or Arbitrum is a piece of technology. You deploy this rollup, it has all these properties. It's a protocol, but like the RAS company can provide you with an additional layer of like guarantees and stuff like that. So I actually view them as really synergistic in a way. Like, for example, you can even imagine that Succinct, like we use our own protocol as like a fulfiller for proofs. And like it gives us cheaper prices than us deploying to Amazon or AWS. I think it's also worth talking about the benefits of the decentralized protocol, because I think a lot of people ask, like, why is that necessary? I'm not a super big believer like in decentralization for decentralization's sake. So let's talk about why decentralization is really powerful. Well, in this case, like our protocol is super, super powerful because it induces this global free market competitive mechanism to surface the lowest prices across the world for proving. Our centralized like prover today, like at Succinct, we run this, runs on AWS. The GPUs on AWS are very, very expensive, much more expensive than like bare metal data centers all across the world. And perhaps our team could go do BD with like random data center providers in like Asian countries. And like to a certain extent, we've tried to do this, but it's really difficult. Like we don't speak their language. We have to figure out deploying to all their servers. Like it's just annoying. Then we have to do all the CapEx and OpEx for like, giving them money and all this stuff. it's actually simpler for us if we just say, here's a protocol, you can use it, and then people all over the world can just coordinate by themselves and respond to like the market pricing and like, you know, the market signal and like, okay, what is the demand for this stuff? What's like the pricing for this stuff? And just go do that themselves. So I actually think in some ways like our protocol and marketplace like solves a lot of problems even for ourselves, and will just make this whole like global scale ZK deployment a lot more efficient and competitive, and therefore drive down prices for everyone and result in a lot of like end user benefits. So that's why I'm most excited about our protocol.
Nice. So it's like a more streamlined way, while at the same time you're having those incentive components, and then you have liveness guarantees, you have low latency. So trying to like optimize for all of those aspects. Got it. And I'm also very curious to hear about some of your thoughts on client-side proving. Like server-side proving and having these proof marketplaces, proof networks are becoming really popular, and people can just kind of like request proofs as opposed to doing it on their own hardware. But are there any kinds of caveats for this where maybe client-side proving is still needed, say within privacy-based applications? Or do you think like with the proliferation of just these proof marketplaces, proving services, applications like some people are working on mobile proving or just web-based proving, are those not really needed anymore? Just curious to hear your thoughts about that.
Yeah, so client-side proving, I think for use cases like ZK identity or like interacting with a privacy chain like Aztec make a ton of sense. It is a really different performance profile than something like SP1, where we've really optimized it for GPU and like running in these big beefy servers with a lot of GPUs. So I think, again, they will always both exist. For client-side proving, I think, again, it's very useful for privacy use cases, but I also think there are situations where sometimes users may be comfortable with doing private proving, like outsourcing their proving for private information to a server. And actually, like, we have an upcoming product release we're working on right now where basically we run proving in a TEE. So you take your private data, you encrypt it with like the TEE's public key effectively, and then only the TEE can decrypt your data and then run a prover and then send you back your proof. And so that's a way to get private proving, but not on your phone. And so I think I'm like, once again, like I'm not really like extreme about any of the options. It's like, okay, if you don't need privacy, obviously just like use a proof network. It'll be super cheap, super fast, really competitive. If you want privacy for your proving for the given use case, then either, do it on your phone. But if you're fine outsourcing it to this like TE proving thing or something else, or fine trusting someone, then that option is also available for you.
Yeah, so depending on the use case. And it's also really great to hear that you're kind of providing users with a lot of different choices.
Yeah. So
if they're, as you say, comfortable with outsourcing, they can use that TE-based model. Otherwise, they can just, do it on their own hardware.
Yeah.
Got it. And I wanted to hear more about some of the recent developments that SP1 had. I know you guys had quite a lot. Recently, you guys announced HyperCube, so using those multilinear polynomials as opposed to, I believe you guys were using the Plonky 3, which had the Stark-based proof system. So very curious to hear about the motivation that you guys had in kind of developing your own proof system as opposed to kind of like the traditional approach, the Plonky 3 approach, or just using the Stark-based proof ones.
Yeah, so Starks have been around for a while, and I think everyone in the industry has been using them and like kind of converged on that. But like when we took a look at the landscape and we looked at our SP1 Turbo version, which was our really optimized Stark version that was state of the art, we felt like maybe there was a 2 to 3x to be squeezed out there through like more performance engineering, but we'd really kind of reached a point of diminishing returns. And we were like, if we want the next 10x, we have to build our own proof system from the ground up and use like the latest advances in cryptography, even make some of our own, and use the latest technology to really get that 10x. And multilinear polynomials are these techniques that I think some people have been experimenting with, for example, in Jolt. Like Jolt is more recent. And I think a lot of people have been finding them very promising because basically in multilinear world, you have like more degrees of freedom, and that allows you to like do things with it that are just more efficient and more expressive. So it's more it's like the proof system is more complicated, which is why let's try to go for like the 10-20x with multilinears. And it's a lot more work because you have to build your whole proof system, which again isn't just like, oh, you make the algorithms and you do the cryptography. It's like you also have to make all the GPU stuff from scratch. And you have to develop new cryptography like techniques. And our head of cryptography, Ron, and a bunch of people on the team developed this new like PCS called Jagged, which they published as a part of our HyperCube work. But yeah, that was the main motivation, is we just really wanted to like go for the order of magnitude gains and speed ups and have a lot more room to run in terms of how much this could be an improvement over our previous state of the art.
Got it. Yeah, and it's great to see like how many kinds of improvements we're seeing even on the cryptography side as well. So I guess like a lot of teams are focusing really on the hardware side, but really great to see that more optimizations are being made on like all different parts of the stack. Yeah. And I feel like all of those improvements together can really make that kind of like, say, 10x improvement. So that's great to hear. And also just on the conversation of hardware acceleration, I know that the Succinct team is like looking into FPGAs as well. So I was curious to hear about just your thoughts on the acceleration, like hardware acceleration.
Yeah, piece. Like custom hardware.
Yeah, exactly. Yeah. And yeah, I know you guys have your own kind of GPU clusters and orchestration like techniques for it. But yeah, curious to hear, especially as our hardware is becoming more advanced, we're making more developments, where you see ZKVMs like Succinct in terms of utilizing these types of like different types of hardware.
Yeah, definitely. So we don't have any FPGA efforts internally, but actually there's this team called enshrined that made their own SP1 FPGA prover. And actually they got really great results, like 20x faster than CPU. And they really did it without talking to us at all, which is super impressive. And I think shows kind of like the power of having this global competition. Like there's these people just doing stuff we could never do. And they're motivated to do it by the promise of like the network and the promise of like the demand, being connected to the demand side on the network. So it is a very exciting area. I think I am short-term bullish GPUs, long-term bullish custom hardware. I think GPUs are kind of like the 80-20, where they're really easy to program. It's consumer grade. It's deployed in data centers all across the world. So I think GPUs will kind of be king for a while. But these custom hardware efforts like FPGA or like ASICs, or, there's teams like Fabric and Irreducible that are working on ZK custom hardware. I think in a few years, those teams will make a lot of progress. And it is like kind of endgame correct to have custom chips for all these ZK proving workloads.
So right now, you're like seeing more or like advocating more on the GPU side, but in the future, definitely we can see some custom hardware being incorporated, like with ASICs and FPGAs. Got it. Yeah. And yeah, also in terms of recent developments as well, I know that you guys have been supporting the Blake 3 as well, like specifically for Bitcoin verification. So wanted to hear just your thoughts on any kinds of like new use cases or any applications that you see developers have in terms of like using ZK on Bitcoin.
Yeah. So, I mean, obviously, I think ETH has led the trend on, ZK being useful for scaling their base layer through the rollup-centric roadmap, and now with real-time proving for the L1 for many years. But the Bitcoin people like are starting to wake up to the fact that ZK can also help them scale their chain. And I think especially last year and like earlier this year, this concept of like Bitcoin rollups was very popular. And there's also some advances on the Bitcoin side with Stark verification on the base layer that kind of was the impetus for all that activity. So we have a few teams in the Bitcoin ecosystem that like have been using SP1 to build their rollups that settle to Bitcoin. There's a lot of different like forms of that, that's like there's BitVM, there's other stuff going on. But in terms of use cases, I think it's all just about scaling. It's like we have Bitcoin, this like amazing global dominant asset. And, people want to do more stuff with it. People want to like lend against it. I think that's like the biggest use case. Today, a lot of that activity is done off chain. What if we could do it trustlessly on-chain? And if you're a Bitcoin maxi, you want to use the security of Bitcoin, not like rely on the security of ETH or bridged Bitcoin or whatever it is. So yeah, I think like that's kind of what some of the teams who are building with SP1 on Bitcoin are like focused on.
Yeah, and it's really great to see kind of how expandable ZK is for these different ecosystems. Like with Bitcoin, we can have more programmability just by having ZK being compatible with Bitcoin. And like, as you mentioned, some use cases, perhaps even like Bitcoin-backed lending, or I know a lot of people are talking about Bitcoin-backed stablecoins as well, which weren't even possible like without BitVM or just like using ZK with Bitcoin. So yeah, pretty exciting where we can see those, range of applications go. And also wanted to talk to you a bit more about some of the integrations that you're really excited about that Succinct, either on the SP1 side or on the Proving Network side, has like recently integrated into. Last week, actually, Uma and I had a conversation with Matt from Across about that integration. I know that you guys are also working with WorldCoin, proving World Chain, which I think is super exciting as well. So any kinds of like new integrations you're particularly excited about, or any that you wish to see being implemented in the future?
Yeah, I mean, honestly, there's so many people using SP1. It's like, I feel like we have an announcement every other day, and it's like hard to keep track of. Some really standout highlights. I mean, you talked about World, which we announced today. So we did a pilot with World a few months ago to ZK prove World Chain. World Chain is a really big chain. It's like the third biggest chain by activity, I think. Third biggest OP stack chain by activity. It's like Base, then maybe OP mainnet, then World. So they do a lot of TPS, a lot of MGAS. And yeah, we successfully ZK proved their whole chain for like a week and showed that, hey, ZK is like here. It's like scalable. It works even for the highest TPS chains. And yeah, like people like World can use it today. So that was a really exciting pilot. We learned a lot of lessons from it. We really stress tested our technology. We even implemented like a lot of fixes because like our cluster had never undergone that much load and scale. And overall, I think it was like a really productive experience for both sides. For us, testing our infrastructure at scale, and for World, giving them the confidence they need to one day fully move over to ZK permanently and not just a pilot. That was exciting. I think another really exciting mainnet that went live recently was Katana. So Polygon kind of, Aglair is obviously their protocol to like unify all these different L2s and have unified liquidity. That's built fully with SP1. And then Katana, which is a chain they incubated, I think it has like 200 million TVL, probably it's more now, went live on mainnet recently, again, powered by SP1, so proving with SP1 and OP Succinct. And yeah, it's been working great. So that's also been exciting. There's a lot of proofs they're pumping through the system. I was like looking at the number of GPUs they're using. It's like hundreds of GPUs. So yeah, that's like been exciting to see in action and just working, and it just works, which is cool. Outside of rollups, which I think is like a use case that maybe everyone's a little sick of hearing about. Like we've talked about ZK rollups for a long time, and now it's like everyone's like, yeah, it's gonna happen. It's happening. Bridging is an exciting one. So that thing we did with Matt from Across, where basically they're taking an Ethereum-like client, written in SP1, so verifying these ZK proofs of Ethereum consensus on a bunch of different chains, empowering the V4 of their protocol that's like expands to many, many chains using these ZK proofs of consensus. So yeah, that was exciting to see go live. Lido recently, moved into their repo this like SP1 accounting oracle POC, where basically right now they have this like multi-sig of I think around like 8 guardians that kind of do the accounting for how much like stETH or ETH rewards are in the Lido validator addresses. And actually one of them got hacked a few months ago. And they want to replace or augment the security of that like 8-person guardian committee with a ZK proof of like the accounting balances. And so they just wrote a Rust program in SP1 and have the ZK proof. And I think that's something they want to put on mainnet later this year. And it's under active development. So across all those use cases, yeah, you see like L2s, both Ethereum and Bitcoin. You see bridges. You see these ZK coprocessor or accounting type use cases coming real. So I think there's just like a lot of exciting stuff across a bunch of different verticals.
Yeah, absolutely. And even on just like the rollup side, it's pretty incredible to see how those like OP-based rollups can really be so easily upgradable to ZK rollups as well, which is really great. And you mentioned lots of other use cases on the interoperability side, even that Lido case that you mentioned. So yeah, really, really great to see kind of all of these developments being made. And just on that topic, I think one of the reasons why why there's so many integrations right now is because it's just ZK is so much easier to use than it was before. And that's something else I wanted to talk to you about, just about the developer experience. So like for Succinct, just for like using SP1, developers can just write a standard Rust-based program and then generate ZK proof and then verify it without having to worry too much on like the cryptography side. So wanted to hear more about kind of like the main properties or just priorities that you have in terms of the developer experience and really how that compares to some of the other approaches that we're seeing, like with ZK DSLs and before when we had to just like handwrite circuits, which was a pretty big headache. So just curious to hear more about some things that you really prioritize on the developer experience side.
Yeah, I mean, I think at this point, like the just write Rust, just write normal code has become very like consensus almost. Actually, one exciting use case I didn't talk about is the CLOBs stuff that's been super popular recently. So these like CLOB stands for Central Limit Order Book, or these verifiable exchanges, where basically, again, it's similar to a VAP in IDN construction, where you have like maybe the matching done off chain, done in real time, Web 2, centralized exchange user experience, but then you have like the proof of like matching and the order book and kind of transfer of funds all be written in business logic and SP1 and then run through SP1, proven at SP1, and then verified on chain. So you basically just have like an unruggable SEX.
Oh, okay.
Yeah. So that's been like really exciting. And we have a few different partners working on these like verifiable exchanges, or they're called CLOBs, verifiable CLOBs. And all of them actually like, they know nothing about cryptography. Their teams are like traders, like people who are experienced with protocol development. And yeah, they just write their business logic in normal Rust code, stick it through SP1, and that's that. And often SP1's like the easiest part of like their integration. It's like super simple, super straightforward. The Rust part's super easy. Often the hard part is building out the rest of the protocol, like building out your margining system. Like, I don't even know about all that stuff at all. So that's been really cool for me to personally see, just be like, oh, wow, these people are really uniquely enabled by this experience of like putting business logic in Rust and just verifying it. Like they couldn't really have built their protocols like even last year without something like SP1.
Yeah, nice. And it's really cool to see that there's even verifiable exchanges being built and they can even have the like user experience from a SEX, but have it just be verifiable. I think that's pretty cool. And awesome. I feel like we've just come so long. Like ZK was invented back in the 80s, and then there was a bunch of research being made in the next couple of decades, and then we saw a lot of adoption with the rollups, and then there was the ZK EVM wars, and then now there's the use of ZKVMs, and with all of these integrations here, I feel like real world adoption is like pretty much here almost.
Yeah, it's happening.
It's pretty cool. Sure. Yeah. And just on that topic, actually, are there any sorts of particular barriers that you see that we still need to address? Seems like a lot of the technical barriers are like, for example, as it relates to just like proving costs and then also the latency in terms of the time it takes. It seems like those kinds of barriers have been, I'm not sure if they're like completely gotten rid of yet, but we've been making like pretty significant strides towards there. But are there any sorts of other barriers that you see that are still preventing us from reaching to that kind of real world adoption?
I think on the ZK side, not many. Like it's easy to use, it's fast, it's cheap. It could always probably be faster and cheaper. That's always true. But I think now it's just like a adoption integration story. Like, a lot of these integrations just take some time, you know? If you're a protocol that has like $2 billion or $10 billion, you know, your base, I think they have like $10 billion in your rollup. I mean, you can't just adopt ZK tomorrow, right? That's like a very big decision. There's a lot of money on the line. You have to be careful. So I think adoption will happen. I'm so 100% confident in that. It's just going to take some time because like the nature of these like immutable systems that have a lot of money that are like irreversible, you just have to be careful. So I think there's that aspect. But yeah, in my opinion, the adoption's pre-programmed. Like, it's going to happen. The other factor is maybe like, you know, developers are pretty aware of the power of ZK. But even these concepts like the VAP paradigm where like, oh, stuff can just happen off chain in real time and then you can just throw the critical parts of your business logic you want to be verifiable in SP1 and like have it work. You know, that's like a relatively new concept, at least synthesized in that form, like, you know, earlier this year, right? So I think there's still like some awareness of like what the right design paradigm looks like. But yeah, I think like over the next year, there's just so many people building with this stuff. It is like a really exciting time.
Yeah, absolutely. And yeah, it's pretty amazing to also hear that, like, from what you said, teams like those clubs that you're working with, their biggest bottleneck is not from the ZK side. It's from, so that part is like pretty streamlined. It's pretty simple for them. And I think that's, you know, one of the main things that we're trying to go towards as an industry. Like, people don't even need to think about ZK itself when they're trying to use it. So I think that's pretty cool. Yeah, very curious to also hear about some of your thoughts on some of those other like programmable cryptography primitives that are becoming pretty popularized in addition to ZK. There's some projects looking into using ZK and MPC. There's some projects that are looking into FHE as well. So I'm very curious to hear about your thoughts on those other programmable cryptography primitives, or if you think that ZK here is really like the end game, what we're going for.
Yeah, I think like ZK has definitely entered like the adoption era where it was like in the research mode for a long time. It wasn't clear like what the final form factor would be. And then it was like RISC-V, ZKVM, just write normal code, it just works. And that was the kind of form factor that let people turn the crank on performance and usability. I think technologies like MPC or FHE or IO are kind of going through that transition too, but they're just much earlier. Like, they're still, I think, more so in the research phase and less in the commercialization phase. So I know of teams that are doing really exciting work across all those things. I think like IO is the furthest out, MPC is the closest, FHE is maybe somewhere in the middle, according to my like kind of not super in-depth understanding of all that stuff. But yeah, all those things are, I think, a much earlier than ZK. But overall, they're all quite exciting. And yeah, again, there's some teams like where you can use MPC and ZK, so it's not even like competitive technologies. It's like, you know, additive. So I'm excited to see like what all those companies do.
Yeah. So right now it's like mostly just in the research phase, but you know, ZK is something that a lot of these different applications can use like right now.
Yeah, and have been using. But I think day to day I'm really focused on like the commercialization and adoption of ZK. So I'm pretty like heads down and just like talking to customers, you know, getting them, making sure they're happy, making sure their questions are answered. So I think I'm actually less aware of like the other stuff going on in cryptography maybe than some other folks.
Got it. Okay. Yeah, that makes sense. And just curious to also hear about some of like Succinct's visions and also values as well. I know that Succinct is really committed to being open source. Yeah, really curious to hear about, you know, what your thoughts are on just the importance of open source in the ZK community as well as just the greater, I guess, like Web3 industry.
Yeah, I mean, I think so many things in crypto are open source, kind of as like they have to be, right? Like if you know, are using a system to custody a ton of funds, you need to know like what that system is doing with the funds. Or even all these ZK programs, like it's not, you can't just have a ZK proof. You have to have like you have to know what the program is that you're doing that is like what it's proving. Yeah, it's succinct. I think we have a lot of stuff that's open source. I mean, the SP1 repo is open source. We plan on open sourcing HyperCube when it's, you know, fully finished and audited. And even with SP1, like a lot of teams have forked it and, you know, made their own improvements, added their own precompiles, you know, like added their own optimization tricks, come up with some clever stuff. So it's kind of been like this branching ground of innovation, which I think is interesting. At the same time, like some of our components are still closed source, and actually some people don't like that. You know, our GPU prover is closed source, our multi-GPU cluster code for right now is at least is closed source. And yeah, I think a lot of people in crypto are kind of open source maxis, so I guess they don't like those things being closed source. I think I'm, again, just a really pragmatic person, so we keep those things closed source for now because like there is kind of this competitive element, and we don't necessarily want people just like forking our code, including our GPU code, making a few small changes and being like, oh, we're now the fastest ZKVM, because like that's happened a few times and it's like not that fun because like, we put a lot of effort into all our stuff. So I think there's a role for both open source and closed source and being pragmatic, or like because ultimately you're building a product and a business. But that being said, I think like we'll probably open source a lot of that stuff in the future. And then it can be interesting because like instead of people forking it and like building their own competing thing, they can add back to it. And like we can really have this like global hive mind pool of talent just like contributing all back into this one repo. Like that'd be super awesome. I think for me, it's like a timing question and like more of like a business question.
Got it. Yeah. But I think the main vision of open source is, what you said, like everyone kind of contributing to that hive mind vision, as opposed to, you know, like trying to build all these competing components. So,
yeah, exactly.
Yeah. Really great that you kind of like mentioned that part, that's, you know, one of the core reasons why we're all really committed to open source. So that's great to hear. And I know that like in terms of Succinct's messaging in general, you guys really emphasize yourselves not just on ZK, but providing provable software. Just like how, you know, like even with other applications with the early internet, we have the foundational infrastructure. We have all of those like web apps that were being developed on top. Even as we're seeing with AI, we have the LLMs as that like fundamental infrastructure, and all those AI applications, agents, whatnot, being built on top. And like even similar to ZK, with ZKVMs being that foundational infrastructure and different applications being built on top. So I wanted to hear more about how you see kind of ZKVMs in this like overall really broad landscape, and what its role is in provable software.
Yeah, I mean, our company motto is informally prove the world software. And I think the reason we chose that is just to show that ZK is so much more than like blockchains or like crypto or anything like that. Like with SP1, you can really just take normal code and normal software and prove it. So, you know, I think that's super powerful because it's not just like, oh, you prove the world's rollups or you prove the world's EVMs or something like that. It's like now you can just make an exchange with like whatever logic it has and like matching and stuff, and you can just take that piece of software and prove it. You can have a protocol that's like ZK KYC where you're like, okay, I want to show that, you know, I'm 18 years old and like, you know, I have all these other properties, but, you know, I don't want to necessarily show off my address or, you know, my exact date of birth. And you can take that business logic and just prove it. Or, you know, in a future where like you have like these compliance checks, you could imagine that the government just publishes, here's the program where like I want people to like, you know, show these properties about themselves before they go use this application. And then you can just generate a proof according to that program with your inputs and just submit that proof. So yeah, I think that's why we chose this very grand and big vision of software, because like, yeah, ZK can go beyond rollups and blockchains and even just verifiable exchanges. Like, I think there's a world in which it's used to like, you know, make identity in the KYC regime a lot more sane, right? And like, now you don't have to like give corporations all your data all the time. It can be used by like insurance companies and, you know, credit scoring agencies to like, you know, inject verifiability into their systems so that they can prove that they're running fair algorithms and giving you like fair insurance premiums or giving you a credit score that's like not biased. So I think, yeah, the verifiability, there's like many places it can be used, even beyond blockchains. And I'm also excited to see that thesis play out over the next like 5 years. Yeah.
Yeah, and I think that's one of ZK's kind of biggest selling points is that it's not just for Web3, not just for scaling rollups, not just for using for the EVM, but even with these other use cases, like you mentioned, identity KYC based, and some projects are even looking into ZKML. And then even like proving, say, IoT devices, that's something else that seems to be like another big like non-Web3 based use case. Yeah, really great that you kind of have this like grand vision for like all different kinds of applications, not just within the Web3 space, which is great to hear. And yeah, just as a last question before we close up, are there any kinds of announcements you'd like to make, or any type of like, I always ask our guests if they have any advice they'd like to give to the audience as well. So announcements or advice.
Well, I think there's a lot of exciting announcements on our Twitter, like customers, use cases, partners. And obviously, we've been running our Prover Network testnet for a while now, and it's kind of in its final phases before mainnet. So there's going to be very exciting announcements about our mainnet soon. So like, stay tuned for that. And yeah, in terms of advice, I think the advice I'd give to a lot of people in crypto is, I think right now is actually a really interesting time. You have like these RWAs, you have these institutions coming in. You finally can build a lot of stuff without being like fearful of like the government or, you know, regulation, because things are a lot more open. And the technology is also like really advanced to a point where you have very cheap transactions on layer 2s. You can just throw business logic and Rust and like put in SP1 and get going with a verifiable app. So I think it's a pretty exciting time in crypto. There's a lot of stuff to build. So yeah.
Yeah, nice. Get building. Yeah, but yeah, thank you so much, Uma, for all the insights. Really enjoyed hearing, you know, not just on developments with the Succinct side, but then also just like the overall landscape, what we can see, what we're currently seeing, our learning. So really great to hear all of that from you.
Yeah, definitely. Thanks for having me.
Yeah, thank you. Yeah. All right, thank you so much.